It is with great pleasure that I will be introducing your area unit. So first, let's look at a couple of square units. Let's say we have a couple of squares here. Alright, so let's say this measures 1 centimeter by 1 centimeter, and let's say this guy right here is, let's say, 1 foot by 1 foot. This first entry is, it has area 1 square centimeter. That's an example of a square unit. Notice, in order for it to be a square, base and height are the same, and the base is perpendicular to the height. Similarly, in this square as well, we measure 1 foot by 1 foot. This has area of 1 square foot. So both of these are square units. And again, square units, you have the same base and height. Again, they are literally little squares. So if you look down in any classroom, this is perfectly true. Each one of the tiles is a square foot. Please make sure that you have that square symbol there. So it's a foot by a foot. If you multiply feet by feet, you get feet squared. So that's why this has area of 1 square foot. This has area of 1 square centimeters. So here's a couple examples of square units. So area in general is the number of square units of space enclosed within a boundary region. So let's look at an example. Let's say I was trying to figure out how big my desk was at school, and I looked, let's say, at the tiles. Let's say I noticed that the height of my desk, let's say, I'm kind of looking at this from a top view, was 3 units large, and the base was, let's say, 4 units large. So again, this is 3, and remember, this is in feet. If we're looking at, let's say, the tiles in my classroom, this measurement right here would be 4 feet. Well, if I wanted to know the area of this region, and keep in mind that my desk does have a perfect perpendicular there, I can multiply 3 feet by 4 feet. 3 times 4 is 12. Anything times itself is squared, so feet by feet makes feet squared. But let's actually really use our area definition to see how this looks. We can literally fill my desk, or my desk is taking the space up of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 square units where our units are in feet. So 12 square feet is how much my desk in my classroom takes up. So this is a perfect example of area, and you can literally multiply base times height. That's actually the area formula of a rectangle, which I'll be going over in a little bit. Now, the most important feature of this unit, and I'm not going to write it in, but I want you to write it in. I want you to start and write it in. In order to measure area in any way, you'll need your base and your height to be perpendicular to each other. That way you can, in fact, generate these square units. Like it's implied that each one of these little lengths is a foot. So not only are they congruent, but they're actually perpendicular to each other so that you can tile the plane. You need that. You need your base and your height to be perpendicular. Otherwise, it wouldn't make sense to have any other shape other than a square, because squares fit so well together. But also just keep in mind, in order to make squares, your base and your height need to be perpendicular to each other. Otherwise, you're just doing random things that don't actually make sense. So pay close attention to square units, and here we go. So now that we know area is kind of how much space you can take up in a two-dimensional sense, how many square units you can enclose or fit in a certain region, we have a couple of formulas. The area of a rectangle we just saw on the previous slide is base times height. Now keep in mind that most important idea is that your base and height must be perpendicular so that you can, in fact, make square units. The area of a square is going to be side squared, and we'll explore that further in a moment. So again, here's my rectangle. We know opposite sides are congruent. Here would be my base, and perpendicular to that would be my height, and I can multiply them together just like on the previous slide. Now let's say I had a square. Well, the base and the height are the same, so let's say I call the base S. The height is also S, so if I multiply base times height, kind of treating this as a rectangle, I have S times S. And we know that anything times itself is written as squared. So these are two formulas, but in essence, I think of both of these formulas as truly just base times height. All right, so let's crush an example here. Let's find the area of this figure right here. All right, so I know that I have a square, and let's say we're also given that this diagonal is, my voice is kind of tired, it's late. Let's say that that diagonal is 10 meters, and the directions would say, which they don't, but I'm verbally saying, find the area of this square. All right, so let's see what we would do here. Well, we do know that we have an isosceles right triangle, so the base angles must be congruent. Oh, look, this is a 45, 45, 90 right triangle. Therefore, I can crash my diagram with x and x. The legs are congruent. They're identical. And the hypotenuse is x root 2. Therefore, we're going to make an equation out of this. We'll try and solve for x, because then we can have our base and our height. Notice how they'll be perpendicular to each other, and we can find the area of the square. All right, so the area of a square. All right, well, first we got to do a little work here. Again, before we get to that area of the square, we have to have a little scratch work where we have 10 equal to x root 2. So now, if I'm trying to solve for x, the length of each of the legs, I will divide by root 2, because I was multiplying by root 2, and I'll apply the inverse operation. I will multiply numerator and denominator by square root of 2. That's known as the number 1. I will have 10 root 2 over root 4. The square root of 4 is 2. I've got 10 root 2 take half. So I end up with 5 root 2 on each of the legs of this isosceles right triangle. Now you can also check yourself. If each of these legs are 5 root 2, if you multiply or scale them by root 2, you should have your hypotenuse. So what is 5 root 2 times root 2? Well, root 2 times root 2 is root 4, which is 2, times 5 makes 10, so our hypotenuse is 10. So we know we did it right. All right, so now the area of the square is going to be our base, which is 5 root 2, times our height, which is 5 root 2. Now keep in mind we could write 5 root 2 squared, but why bother? So I'm going to rearrange this because all of these numbers are multiplied together. So I'll have 25. Square root of 2 times the square root of 2 is the square root of 4. The square root of 4 is 2. 25 times 2. So my area will be 50. Okay, now you need to pay attention to units. Our units are in meters, so now if this were meters, and this were in meters, meters times meters is meters squared. So we literally could fit 50 square meters inside of this square with a diagonal of 10 meters. So you really need to make sure you can do a problem like this. Feel free to pause it and start it over or give it another whirl. So we have the concept of area, and we understand that square units are crucially important, and we'll always need a perpendicular. We'll always need our base to be perpendicular to our height to measure area. Well, here's kind of a funky example where we are given that we are allowed to assume that we have right angles and parallel lines. And here's the other given information. This length is 4, 5, 3, 2, and 8. And the directions would be to figure out how many square, let's say this is in feet. All of these units are in feet. Figure out how many square feet this interesting shape is. All right? So, since we're allowed to assume right angles and parallel lines, what I will first do is break this shape into 3 composite shapes. I'm actually going to do this example 2 ways. Makes me think of like Top Chef, where they make like the same dish 3 ways, you know, like apple cobbler 3 ways. Well, let's do this problem two separate ways. First, this will be technique number one, where we break this problem into smaller shapes. So let's see, let's kind of, let's see what we can do here. Let's kind of dissect, let's kind of break up this shape. Let's make a rectangle here. We have our base. Now we have our height. Notice I'm not assuming, because we know that there is in fact a right angle there. All right, so this has area of 16 square feet. I'm just doing a little base times height there. All right, so we've sectioned off this C shape into one rectangle so far. Now, let's look at the second portion. Well, here you're going to start experiencing some area arguments. If this entire length is 8 and this is 5, this little piece plus 5 must make 8, so that little portion must be a 3. Arguments like that are crucial. And then, since we can assume right angles only in this problem, we have a rectangle with a base of 3, and perpendicular to that, its height is 4. Keep in mind, I could say its base is 4 and its height is 3. It doesn't matter which way you slice it, just as long as they're perpendicular. So here we have 12 square feet in addition. And last but not least, for this region, well, here we'll call this our base. Here, now this length, keep in mind this 8, we can kind of push it up. This is also our 5 plus 3, so this is 8. So our base is 3, our height is 8. This is 24 square feet in area. So the area of this figure is going to be 24 plus 12 plus 16. I'll do 24 and 16, that'll make 40, and 12 will make 52 square feet. So this is only one way to do this problem. We could break it up in a different sort of way. So this way we broke it up into smaller pieces. Let's check out the next way. So here we have the same problem again, but now we have a Roman numeral number 2, so we're going to do this problem a little bit differently. So we have these same dimensions as before. And now what we're going to do is kind of make a larger shape. We're going to enclose this entire figure, and then we're going to kind of subtract out this region that isn't really part of what we're interested in. Okay, so the area of the figure in this case, let's develop a strategy. This is going to be hugely important. The area of the figure will be the area of the entire shape, which is a rectangle, quite possibly a square, and then we'll take away the smaller rectangle. And please write small into your notes there. Okay, so we have this entire figure, and if we subtract out this portion, we'll get the leftover, which is the area we're trying to find. Again, we may assume right angles and parallel lines. All right, so where are we going to go from here? Let's figure out the entire shape first. Well, this 4, we can push it out. This length will also be 4. You're going to need to do that a lot in the area unit and for the rest of your life, so it's very, very important. So now this entire length is 3 and 4 and 2. That's the artist, formerly known as 9. And remember, our units are feet. Okay. Now, what else can we do? Don't forget that we also have a dimension of 8, and we were already given that in the problem. Don't worry, I just forgot to copy it down. Let's go with it. All right, and just like in the previous problem, that 8 was there in the beginning. We can assume right angles here, so I guess we have a base. This is our base, and perpendicular to that is our height. And since we, can assume our parallel lines, this and this are the exact same, so we have our 9 feet here. So we could say the area of the larger rectangle is 72 square feet. That's base times height, 8 times 9. But now we're going to subtract away this region in here that we aren't using. Again, we may assume our right angles here. You may not assume that unless we tell you to. We have a rectangle with a base of 4 and a height of 5, or vice versa, a base of 5 and a height of 4. That has area 20. square feet. We're going to subtract that off, and we'll get an area of 52 square feet. So that's like how many, we could fit 52 of the tiles in your classroom if you look down in this region. That's what it means. That's how much area we have. All right, so real quick, team. Let's say you have a rectangle. Here's your base, perpendicular. Remember, you need that right angle to make your square units. Perpendicular to that is your height. Well, you might be wondering, well, what's the area of a triangle? The area of a triangle is going to be, well, notice, this is a rectangle. We know its area is base times height. But if we take the diagonal, bearing in mind that the diagonal cuts this rectangle into two equal parts, you could argue that that's by side angle side. These two triangles are congruent. Two halves make a whole. Well, then the area of a triangle, let's say this triangle right here, it would be half of the area of the entire rectangle. So it would be half of base times height. Now keep in mind, we could write that as base times height divided by 2. Both of these things are saying the same thing. So that should come as no surprise. The area of a triangle is half as big as the area of a rectangle. So just one example for you. This will be your practice to show that you've really studied this material. So your challenge is going to be to find the area of this funky shape. I'll give you a right angle right here. I'm going to tell you this portion is 5, this portion is 9, this portion is 12, and let's say that they're all in terms of, let's say, inches. So your challenge is going to be to find the area of this figure. Now keep in mind, you should break this into pieces, like you could break it into maybe a square or a rectangle or a triangle. But always keep in mind that you need right angles so that you can find square units and actually figure out the area of the shape that you're dealing with. So the challenge is for you to find the area of this figure. You're going to have to break it into a couple of parts and try and break it using right angles. That will be crucial. Good luck. I hope this video was informative.